Today we're going to cover section 4.3, logarithmic functions. Well, what is a logarithmic function? It's the inverse of your exponential function. What does an inverse do? Well, that switches your inputs and your outputs. So previously, if we had something like a raised to the y is equal to x, we write the corresponding logarithmic function as log base a of x is equal to y. So we're going to use this definition to evaluate some expressions. And the first one we're going to do is evaluate log base 2 of 8. So we want this to equal some value y. To determine what y is, let's write out this expression as the exponential function. Our base was 2. We raise this to the y, and this is equal to 8. You may recognize 8 as 2 raised to the third power. So from here we notice that we have the same base, and if we have the same base, then what does y equal? Y equals the exponent that matches, so y is 3. We're going to solve most of our questions like this. So b is going to be log base 2 of 1/4. We want to evaluate that expression. Again, we write this out as equal to y. We rewrite this as an exponential function. So this would be 2 raised to the y is equal to 1/4. We may recognize this as 1 over 2 squared. And if we have our base in the denominator of a fraction, that's the same as moving it up to the numerator but having a negative exponent. So this is 2y is equal to 2 raised to the negative 2. And if that's the case, then y is negative 2. Continue on here, and we'll do c. Then this is the natural log of e squared. We want to solve that expression or evaluate that expression. Again, we write this as equal to y. So what is our base for the natural log? Our base for the natural log is e. So here we write e raised to the y is equal to this thing on the inside of our expression, which is e to the second. Well, again, we have e and e as our base. We have e as the base on both of these. So then y is equal to 2. We can continue on to do one more example of this type. So here we have log base 10 of 0.01. Again, this is equal to y. We may recognize 0.01 as 1 over 100. So this is 10 to the y is equal to 1 over 100, which is 1 over 10 squared, which is equal to 10 to the negative second power. And here we see that again y is negative 2. I want to do another example that's similar, but not quite the same. So here I want to solve the equation. Log base 3 of x is equal to 4. We do this just like we did above, and that is to rewrite this as an exponential function. So this is 3 raised to the 4th is equal to x. Well, if we multiply 3 times itself 4 times, we get 81. So here x is 81. I have one more type of problem that we want to do for this section, and that is to graph the equation by transformations And this equation is log base 3 of x minus 2 plus 1. So we've done transformations quite a bit, but we're going to do it again here. The first thing is to draw the base function, which is log base 3 of x is equal to y. To do that, we might recognize that when x is 1, we get y is 0. We'll see that by 3 raised to the y is equal to x is the corresponding exponential function. So when y is when y is 0, x is 1. And when y is 1, x is 3. And we can use that to plot our base function. So x is 1, y is 0. X is 3, y is 1. And our general logarithmic function looks like this. So we've graphed y is equal to log base 3 of x. And here again, we want to graph the function log base 3 of x minus 2 plus 1. Well, what does the minus 2 on the inside of the function do? That moves everything to the right 2 units. So we'll do that here. Move 1, 0 over to the right 2 units, and we get 3, 0. We move 3, 1 over 2 units, and we get 5, 1. And we again draw the logarithmic function. Here our asymptote, our vertical asymptote was x equals 0, and now that it would be x equals 2. So we'll have that asymptote again. And the last thing to do is to add 1. So we just move everything up 1 unit. And we want to draw this same shape. So again, this is our final graph here, which is log base 3 of x minus 2 plus 1. And that's it. That's how you graph logarithmic functions by transformations.